All right, guys, so today's questions that we're going to go over are called rate of flow questions. I call them the in and out questions when either people are moving in and at a certain rate and people moving out, or we have liquid leaking out when liquid is being filled in. You see this often in different scenarios presented to you. And I always told you in class, I think these are pretty difficult only because you're working now with two equations simultaneously from the very beginning. We're used to, with the AP questions in the past, dealing with getting a new equation at the end, but we're getting two equations right from the beginning. So just like always, you want to read through the question. And I'm going to go over 2002 and the second question on the worksheet, which I believe was 2013, and then the last two you try for homework. So when you read this, it says at the rate at which people enter an amusement parks, and they give me E of t. So I already know this is a rate, and this is being measured as people per hour. Now I already wrote down the information, and I went ahead, because you're going to use your calculator for these, I went ahead and plugged in those two equations right into y equals 1 for E of t, and y2 is carrying L of t. Okay, so basically what you want to see is what these two equations are representing. E of t is representing the people that enter the amusement park, and then the rate at which people, the same day, they say the rate at which people leave is L of t. So what I normally do is I write myself a little note here, and I go, all right, this is my in equation, and this one's my out equation. All right, then I went ahead and read the other information. They're both being measured in people per hour. They're telling me that that T is measured in hours after midnight. And then this is interesting. They tell me that the domain, this is only valid from 9 to 23. We're used to just assuming that it's valid from 0 on to the present, but they're telling me that these equations only work from 9 to 23. And they go ahead and tell me that when T is equal to 9, there's no people in the park. That's an initial condition. So I wrote that down over here too, that when T is equal to 9, there's 0 people. So the part of the AP, they got rid of Unit 8, which was what we called the accumulation problems. How much has accumulated in that time. But you kind of have an idea with it because we've discussed position functions where we said, well, where was I at a specific time given by the initial condition? And then we added to that output the integral of velocity, which gave us the position function. So question A is kind of looking very similar to that position function. Questions A is saying how many people have entered the park by 5 p.m. So now let's think about it. I want how many people entered. They're saying nothing about leaving, so I'm just going to worry about E of t here. And when I say how many people, this is people per hour. If I want to get to just people, I know I need to integrate. So I go, okay, I need to integrate the function E of t. And they want to know how many people have entered the park by 5 p.m. and they're saying that's when T is equal to 17. Well, that's up here. But what was my initial condition? At T equals 9, that's my lower bound, there was 0 people. So technically, I'm adding that 0 here. You don't have to, but that's what you're doing. It's just very similar to position, and that's my accumulation problem. So here, since I already have E of t in my y equals 1, I just go to my home screen, and this is a lot of calculator, so I'm not sure if you can see it. You're just going to go math 9 to 17. Big mistake here would put a 0 on the bottom. Go to vars. You're just going to enter the first function, dx, and I'm just seeing if you guys can even see my right there. And it's going to come out to give me 6,004, and they say round to the nearest whole number. So we have 6,004 people have entered. So that's what you would just write, people entered the park by 5. Okay. Part B, they go on to, that was A. the price of the admission of the park is $15 until 5, and then it's 5, and then after 5, the price of the admission is 11. How many dollars are collected? Well, you know, if I want to know how many dollars were collected, you would have to just take 15 and multiply it. Well, you already know the people that have entered by 5 is 6,004 people, and multiply that by $15. But then I need to know the amount of people that are there after 5. So I go ahead and I just made a big integral expression. So I said, okay, the cost, how much money is collected, is 15 times the integral of 9 to 17 e of t dt, which you could have just written that as 15 times 6,004, but plus it's $11 from, well, what's after that? So it's from 17 to what time? Well, they told me that the park is in hours to t23, so I'm going to put 23 as the upper bound of e of t dt, and I would do that whole expression in the calculator in one shot. So you're literally just typing 15 math 9 to 17. You're putting your vars as y1 because you're doing e of t in there, x, and then you're going to add that to 11 math 9 17 to 23 bars y equals 1 dx, and that's what your calculator should look like. I'm trying to see if it's if you can see it well, and then the calculator comes out to be, you got $104,048. Did they say, they said round it to the nearest whole number, so it's $104,048 for part B. Okay, so here comes C. It says let h of t, and they give you an equation. So I'm going to go ahead and just spin this around just so I have more room. I like to write nice and big so I know that you are seeing this. So we got that h of t is equal to the integral, and that says 9t e of x minus L of x dx, and they say that the value of h of 17 is equal to 3,725. They want me to find the derivative of h of 17 and explain the meaning of both h17 and the derivative of h17 in the context of the park. Okay, so first of all, let's just talk about what this means, okay? You know this was my in equation. Sorry, just gotta grab another color here. So this was my in equation minus the out equation of people. So now think about what that tells me. If I integrate, now if I have a rate of people per hour and I integrate it, I'm just gonna have people. So this is gonna be the people in minus the people out. So what is that gonna represent? If I have the people coming in and I subtract the people coming out, that's gonna tell me the people that's there at that moment. So h of t represents the people at the park at the given time. So here, h of 17, you would say there is 3,725 people in the park when t is 17, or we know that's 5 p.m. because they told us that. Okay, so now let's talk about what the rate is. Now think about it. This is the amount of people at the park, and we're going to take the derivative of that. Well, if we take the derivative in h prime, it's going to give us the rate of people at the park if it's increasing or decreasing. Okay, so let's see how, taking the derivative of an integral, you know that's the second fundy. So we're going to go ahead, and if it's easier, this might help you to understand this a little bit better. if I just separate this as two integrals, which completely allowed when it's a polynomial as your integrand. And now I go and I take the derivative of that, and this is the derivative of the upper bound, which is 1, times the upper bound subbed in, so that's e of t, minus the derivative of the lower bound, which is just 0, so I don't need to continue. So I go on to this piece. And when I do this, when I go ahead and take the derivative of the upper bound, it's going to be 1 times the upper bound subbed in, so it's L of t d is the derivative. So if I want to know this for 17, all I'm really doing is finding e of 17 minus L of 17. So because I already have both equations in the calculator, so I have E of t up top and L of t on the bottom, all you have to do is go to your second table set. I want to go to auto because I just care about what the value is at the table. Oops, second table set, not auto. I want to go to ask, second table, and I'm just going to hit 17, and I want to know what the value is. So that's telling me that this is 15,600 over 41 minus 9,890 over 13, and you just go ahead and figure out that value. Now guys, I know you could do this by yourself. I'm just walking through this with you so that to make sure that if you have any questions, hopefully this helps you and not bores you to tears, as I would suspect it might. So, okay, so you're going to take this and you're going to subtract it from 9,890 divided by 13. So hopefully our math adds up, and we get that this h prime of 17 is equal to negative 380.281. Remember, we truncate our answer. So now think about it. If h of t represented the people at the park at a given time, well, h prime of t is going to represent the rate of people at the park. So if it's negative, that tells me that the rate is decreasing. So you're just going to say the rate of people is decreasing by 380.281 people per hour. And that would be you explaining the context. Okay, and part D. They go ahead. These interesting. They say, at what time does the model predict that the number of people will be at the maximum? Okay, so I hear the word maximum and right away I'm thinking first derivative. But then I'm looking at the question. It says the model predict the number of people in the park is a maximum. Well, we just said that the number of people in the park is represented by this expression. Right? That was given to us before. So that's representing the people at the park. So if I want a max, I want h prime of t, which we've already done, and we've already said is, what did we say? H prime was e of t minus L of t is equal to the h prime. So what we want to do is look for this function to equal 0, okay? And we want a sign change from positive to negative. So this is all calculator. What you would do is I have in y1 e of t, in y2 L of t. So in y3, I'm just going to put my in minus out there by representing vars and go y minus vars. And then I'm going to hit 0 because I know I'm just going to care about when that function hits the x-axis. So I'm going to unhighlight the first two. I just want to go ahead and just grab